Hello and welcome back to the channel. In this video we'll be going over decimals at GCSE, and let's get started. So the first thing we're going to look at is converting fractions into decimals. Now when a fraction is converted into a decimal, it can either be terminating or recurring. A terminating decimal can be written on a piece of paper and will end. However, a recurring decimal goes on forever. In order to help this make sense a bit more, you can look at 1/3. 1/3 is a recurring decimal because 1/3 is equal to 0.333. The threes go on forever, which means that you can never actually write the whole value of 1/3 other than writing it as 1/3. So that is recurring. However, something like 1/4 can just be written as 0.25. So that is terminating because that is the end of the decimal. So in this specification you need to know how you can determine whether a fraction is terminating or recurring. Now in order to do this, you have to look at the denominator, the number at the bottom of the fraction. If the denominator, if its product of prime factors contains numbers other than 2 and 5, then it will be a recurring decimal. So for example, 7/20, if we look at 20, the product of prime factors of this would be 4 times 5, circle 5, and then 2 times 2. So it would be 2 squared times 5. This would mean that 7/20 is a terminating decimal because its product of prime factors consists of only 2 and 5. However, 16/27, if we take a look at 27, that is equal to 9 times 3, which is 3 times 3, which is 3 cubed. So since it consists of numbers that are not 2 and 5 only, then this would be a recurring decimal. Take a look at the example at the bottom here. See if you can work out whether this fraction is terminating or recurring decimal. Okay, so we have to look at 15 here. 15 is 5 and 3. This means that this fraction is a recurring decimal because the product of prime factors of 15 is 5 times 3, which does not consist of only 5 and 2. So this would be a recurring decimal. Okay, next thing we're going to look at is converting between fractions and decimals. So when converting from a fraction to a decimal, you can use short and long division in order to work out what the decimal form would be. So in this case, 4/25, we can use long division here. So you'd have 4 here and 25 here. Since 4 is less than 25, we'll put a 0 point here, and then we can add a 0 onto here. So we have 40 now and 25. 25 goes into 40 once, which gives us 1 here, and then 40 minus 25 is 15. We could put another 0 here, and then 150 divided by 25 would give us 16. So this fraction is equal to 0.16. An easier way of doing this is if the fraction is a terminating decimal, we can just turn the denominator into a power of 10. So 4/25, we can multiply the 25 by 4 to get 100, and then we'll multiply the 4 by 4 to get 16. So we'll take this number here, and it would be 0.16. you can use either method. The method at the top works easier sometimes, but the method at the bottom can be helpful as well. You pick and choose. Alright, let's free up this space and take a look at this one here. So this one is a bit tougher because it is a recurring decimal, not a terminating decimal, but you'd use the exact same method basically. So it would be 5 and 6, and then here we can add a 0 here and put a 0 point here, and then how many times does 6 go into 50? Well, we'd have 48 here, so it would be 8 times, and then we're left with 2, 0, then we'd have 18 because 6 times 3 is 18, and then we'd have another 2 here, and then this would also be a 0, and you'd have another 18, so it would be 3, and this would keep going on forever, which would mean that 5 over 6 is equal to 0.83 recurring. Whenever you see a number is repeated twice, then that's the end of your decimal, and you just put a point over the parts where that are going to be repeated. Okay, we'll take a look at converting terminating decimals into fractions. We'll look at converting recurring decimals into fractions at a later video, but we'll just look at terminating decimals for the time being. So 0.42, we can actually just write that out as 0.4, no, we just write it out as 42 divided by 100, because that's what 0.42 is, and then we can just divide up and bottom by 2, get 21 over 50, and that is our final answer. Have a go at converting 0.275 into a fraction, and alright, let's go over it. So this cannot go into 100 because 275 is greater than 100, but what it can go into is 1000. So what you have to try to do is, again, get this number into a fraction where the denominator is a power of 10. So in this case it would be 1000. So 275 divided by 1000, we can divide up and bottom by 5. So at the bottom here, 1000 divided by 5 would give us 200, and 275 divided by 5 would give us 5, and then 25 divided by 5 would give us another 5. So we'll have 55 divided by 200, and then we can divide that by 5 again to get 11 over 40. And that is our final answer. Okay, let's take a look at adding and subtracting decimals. When adding and subtracting decimals, really all you have to do is just do it. It's really similar to just normal addition and subtraction, except when you carry on to after the decimal point at sometimes. So in this case here, just do 0.45 plus 0.61, and you get 5 plus 1, 6, 4 plus 6 is 10, so we put 0 here, and we'll carry the 1 up here, and then we're left with 1.06, and that is our final answer. Subtracting decimals is quite simple as well. You just have 4.20 minus 0.83. Notice how I've added a 0 there at the end so that I can have another number in the same place value as the end value of the second decimal. Alright, so here 0 minus 3, we can't do that, but we can do 1 here and turn that into a 1, so it's 10 minus 3 is 7, and then we'll have a 1 here, minus 8, we can't do that either, but we can turn this into a 3 and turn this into 11. 11 minus 8 is 3, and then 3 minus 0 is just 3. So our final answer here is 3.37. Okay, finally then, let's take a look at multiplying and dividing decimals. Okay, so when multiplying the decimals, you have to get them into whole number values first. So here we'd have 54 times by 67, right? and then you just multiply it normally like you would any other number. So 4 times 7 is 28, 7 times 5 is 35, plus 2 is 37, 6 times 4 is 24, and then 6 times 5 is 30, plus 2 is 32. So we would have 8, 4 plus 7, 11, and then 4 plus 5, 4 plus 5, 4 plus 2 is 6, and 3. So we have 3,618, and that is 54 times 67. However, you then have to add the decimal point right here, 2 parts after the end of the number, because here the decimal point, we've moved it one to the right, and here we've moved it one to the right. So we have to cancel that out by moving it twice to the left here. So this would be 36.18. However, when we divide decimals, we don't have to do that, because 8.1 over 3.6 is the same as 8.1 times 10 over 3.6 times 10, because the 10s can just cancel each other out, and so we can just have 81 over 36, and that is absolutely fine. So 81 over 36, we can divide the numerator and the denominator by 9 to get 9 over 4, and that would give us 2 and 1/4, which is just 2.25. If you're given the question and both numbers are given in decimal form, then give it as a decimal at the end, and if you're given them as a fraction, then give it as a fraction at the end. Alright, let's have a look at this final question. A lot of questions tend to come up like this. They would be at the end of the foundation paper or at the beginning of the higher paper, but they do come up quite often. So we're asked to write these numbers here in ascending order. Ascending order means we'd have the biggest number at the end and the smallest number at the beginning. So we'll do this by just let's write all of the numbers out in decimal form. You could write them out as fractions, but I think this one would be easier if we write it out as decimal form. So we're already given 0.3 as a decimal. We know that 0.35 recurring would look something like this: 0.35, 35, and so on. 1/3, well, we can just use long division for that, so we put the 0 point here, and then 10 here, 9, and so that was 3, another 1, another 3, and so forth. So this would be 0.333 or 0.3 recurring. And then 7 over 9 have 7 here, 9 here, 0 here, 0 point here, and then this would be 63, put a 7 here, another 7, and so this would be another 7, because that would be 63 again, and it would go on forever, so this would be 0.777 forever. And so what we do have here is 0.33 recurring, and then 0.35 recurring, 0.777 recurring, and 0.3. So if we write that in ascending order, we'd obviously have 0.7 recurring, that's the biggest number, 0.35 recurring after it, 0.3 recurring, and then 0.3, just 0.3. And then when we give our final answer, we have to give it in the form that we were given in the question originally. So 0.3 was 0.3, 0.3 recurring was 1/3, 0.35 recurring, we'll write it out as we were given, and then 0.7 recurring, we write 7 over 9. And that is our final answer. Alright, that's the end of the video. If you found the video helpful, please do like and subscribe, and I will see you in the next one.